Hello guys, I'm Super Ron, welcome back to the channel, and we are back down the G unit with this absolutely stunning Mk1 Golf Cabriolet 20 valve turbo. So this was a full build completed by someone else for the customer, basically from a bare shell up. It had the engine conversion done, had a full respray in this candy red, it had the wheels, the suspension, the interior. This car was done top to bottom and it is 95% finished. There's just that last 5% when it's not quite running right. So it's come to me to just have that last 5% polished off. What we found in the last episode, the running problems were because of fuel pressure. The fuel system has been fully uprated in AN lines, and it's got lift pump at the tank feeding this swell pot, and that feeds a massive Bosch 044 pump which then goes directly into the rail. The problem I found in the last episode is we have got creeping fuel pressure. I think because the pump is so big and right at the front there's no buffering, it literally comes straight out of the pump, straight into the fuel rail, and the fuel pressure regulator cannot keep up and get rid of the excess pressure. So it is a bit of a strange one because I use these fuel pumps, I use these fuel lines, I use these fuel fittings, I use these swell pots on all of my builds with these 20 valve turbos, and it doesn't seem to be a problem. But with mine, the swell pot and the pump is at the back, so you have 3 meters of fuel line before it actually gets to the rail. I think what the problem is here, because it's going directly out of the pump, it's got about that much until it goes straight into the rail and it's just flooding it with pressure. These Bosch 044s can flow 300 litres per hour, so the standard fuel pressure regulator just doesn't stand a chance. So before I go out to buy all new parts to rectify this, because when you get into the AN world, things do get expensive really quick with all the fittings and everything you have. So with some old bits I have laying around, I want to conduct some experiment, and if they're successful, we'll get ordering bits and get this fuel pressure under control. So the system works, the fuel comes from the lift pump from the tank in here and fills up this swell pot. That then feeds the pump, which is just down there. You can see the end of the Bosch 44. It comes out of that banjo at the end and then straight into the rail. The rail has been converted to AM fittings, just like we use. We use those pressure ones. And what I did is put a gauge in the end so I could keep an eye on the pressure. And as you saw in the last video, it was just out of control. So it comes out of the pump into there, and then we meet our fuel pressure regulator. So this is a 3-bar regulator. So when the pressure reaches 3 bar in the rail, any overpressure gets dispersed out of the fuel pressure regulator, across the top, back into the swell pot. And then when the swell pot's full, that goes back to the tank at the back. So what the swell pot is for is always to make sure the Bosch 44 pump is always supplied with a constant amount of fuel. So this is a really nice setup. The trouble we've got, this is getting up to 5 bar in the rail and the fuel pressure regulator can't get rid of it. I've got another fuel pressure regulator here, and as you can see, that tiny hole in the middle is where the fuel exits. So we've got these huge AN lines coming in at 300 litres per hour. They're getting to the end and it's all got to go through that hole, which just cannot keep up. So when you're checking the fuel pressure regulator, you always have the vacuum disconnected. What this does is it increases the pressure as it sees boost. So this is a 3-bar regulator. So if you have 1 bar of boost from the turbo, that then add an extra bar to the top and raising the pressure. But what we're seeing 4 or 5 bar on idle, which is not ideal. So my long awaited rear wheel drive Astra is sitting over there, and over the years I've been building up parts, and some of that is the fuel system. So I've got this aeromotive fuel pressure regulator, and I've got a few random AN lines. We can get this connected up in line, just a proof of concept to see if we can get this fuel pressure down in the rail. And what I've done with a fuel pressure regulator, because we don't want this restricting the flow, so the fuel is just going to come straight through the rail and then straight through the return. This isn't actually going to be anything. You can see there, I've just chopped the bottom off so it'll just flow straight through up to our regulator. And then if we can wind this down, because this is adjustable and this works, I'm going to go shopping. So let's get this mock up. First of all, let's get her wrapped up. And that is just to protect this gorgeous candy paint as I'm working on it. So I'm going to take this regulator out, get that cut off one in, and then interrupt this line with our regulator. Horseshoe here, have a little bit of a dribble of fuel. Let's have a dribble of fuel from the rail on off. And out it comes, and there you can see inside the 2 chambers. So it comes along the rail into the outer, through the filter around the outside, and then it's got to go back through that tiny little hole down through the middle. So this is our restriction point. So for testing purposes only, we have chopped that off. So it's just going to go straight through the rail, straight down that hole, back out this one to our regulator. Like so. So as said, this is just proof of concept. I just want to see if we can get this fuel pump under control, being so close to the rail. So now this is fully adjustable. I can set it to whatever pressure I want. So let's start it up and see what we've got on our gauge. So we're sitting at about 3.5 bar there. Let's see if we can crank it down slightly. So we've got a lock nut on the top, loosen that off. And then when we turn this, the pressure should change. Yeah. We're down at 3 bar there. So with this under control, I can crank this up. We can have it at 4 bar. We could have it all the way as the pump would flow. But we want to restrict it down to 3 bar. So now that is sitting perfectly at 3, I am happy. So proof of concept works. So we can harness that fuel pump, we can get it under control, and we can have it sitting at a constant pressure. Now in reality, this fuel system far exceeds the requirements for this engine. This fuel system can support probably 500 horsepower. The engine as it stands probably is never going to see 300. A BAM can quite happily run on a standard VW fuel system, but as the owner has already spent the money on all the AN lines, the big fuel pump, the swell pot, and having it all installed, it doesn't make sense to remove it. And of course that'll give the owner the reinsurance in the future if he does want to carry on tuning, if he then goes to a bigger turbo, if then it spirals to forged rods, to internals being done, he will always have the fuel system to support that. And it'll quite happily run at standard power. So now I need to make a little shopping list. But what I'm thinking at the minute, this is a bit of an add-on to add-on to add-on to add-on. The standard fuel rail has been converted to AN fittings with the compression joint. So we've got 3 or 4 fittings going into the rail. We've now got our fuel pressure regulator that's been chopped off and not actually doing anything, just looks normal from the top. We need some more AN lines. So keeping in the theme of future-proofing, I've just been talking to the owner and we've got a plan. So I've made an order with Torx. We've got some bits coming from America, so rejoin me when we've got some new bits to fit. And we are back with lots of new parts. So I got in contact with Torx and got all the fittings and lines we need, and now they do their very own fuel pressure regulator. So this is just like the Aeromotive one that I used before. This is all in their nice Torx logo. Comes with the Torx gauge as well, so we can set that up all in. Also comes with a nice shiny bracket so we can get that mounted on. We've got all our fittings, all the bits to go in the ends. And then, like we saw, we've got the fuel rail, which has got a fitting, a fitting, a fitting, a fitting, goes round. This is now redundant, goes round. We've got fitting, fitting, fitting. That has been replaced by this gorgeous piece from Integrated Engineering. This is a billet fuel rail with no fuel pressure regulator. So this has come all the way from America and it's actually arrived in 5 days. Comes with a nice little beer cooler, and with these fittings, they'll go on the ends. So we'll go straight out of this, straight into our fuel pressure regulator. So let's strip all this bits, let's strip our mock-up off, clear a space for all our new bits. And rail off, and now you can see all the extras that have been added onto the rail, the fittings and these males to males and the females. And we're going to replace that with this nice billet piece, just an AN on each end. Then I've got a 180 to go on the end, so the fuel will come in one end, out, and return back to our little regulator. This comes with different size spacers, depending if you're running aftermarket injectors, which are sometimes longer, but we're running standard, so we've got everything we need in there. And you can't deny how much better that one looked than that whole thing. So let's get this fitted. There's the injectors in. They all work with the factory clips. Everything is billet machined perfectly. Got the fittings on. So now we can just slot this straight in like that, and how much better does that look? Right, let's continue the sequence. And because the feed is pretty much in the same place, the original hose are screwed straight in. We had this big plastic bit that clipped to the old rail that held the injection loom, but I unclipped it all off that, and the loom just tucks in nicely down there, which looks so much more tidy without that loom running across the front. So now we just need to connect this end to our regulator. Now we have got a really nice bit there, which I would love to fill up with the regulator, but I'm not sure how we're going to do it, because AN to AN, male to male is a little bit on the tricky side. But I mean, that would look super cool in there and finish off this rail assembly nicely. I might have a little look. We've got the old lifting eye mount there, which we could mount onto, but I need to try and get a hose from there to there. It's not very easy to go direct, like I say, AN to AN. Alternatively, we can put it over here like I had on my trial, and I can screw it there and we can just run a line all the way across. So I'm going to do a little bit of trialing, but that sitting in there would look cool. I'll see what I can do. So I've just had a little chat with Torque, because what I really wanted is an ORB 10 to a female AN, so then that could screw straight onto there. Unfortunately, they don't do one of them at the moment, but they said that's a great idea, so they're going to add that to their infantry. But for now, what they did say is they do a female to female. So he has sent me one out, and this connects the two AN males together, but they spin independently, so we can lock it how we want. So we put the female onto there, and a male can go into this female. Can go on there. So as you can see, when they're loose, they can go independently, so now we can clock this whichever way we want. So I think that looks pretty cool there. Nice to use that space. I have just had it on and closed the bonnet. And although it does look like it's up quite a bit, there is still loads of clearance to the bonnet. So that should solve all our problems. And then we've just got the fitting that comes off the bottom here. Has got to go along and then to our fitting there. Don't know if it'll be a 45 off the bottom or maybe a 90, but we'll clock this round to where we want. And then I can use the holes on the back to mount it, just so this isn't all hanging off that fitting there, because that could quite easily break off. It'll have the support from the mount on the back. I've taken their mount off at the minute. That mounts to the back of the fuel regulator. So if we just put a little bend in this, we can mount that to there, and that'll be a nice solid part of the engine. And then with our colour-coded Torx wrench, we can do these up and then locate this whichever angle we want. I'll try and get it as aesthetically pleasing as possible, but the main thing obviously is to get it to fit under the bonnet, which this will perfectly. So that is going to work out nicely. We could quite easily just mount that over, drill some holes on the inner wing, run the hose to the rail and then all the way off and then back to the regulator and then back to the swell pot. But this makes it sit nice and compact, and in theory the closer we get the regulator to the rail, we're going to have the exact pressure in the rail, even though in reality it doesn't really make that much difference. Some cars these days have the regulator in the back of the car, so the whole fuel system is pressurised but the reading is taken at the back. But like this, it looks nice and cool, nice and compact, so that sounds good to me. I'm going to get this bracket bent, made up, and then start running our fitting. Now that is looking very racy, so let's get this mounted properly and start connecting some lines up. So I've been having a little play around with the brackets. Basically what I want this to be is to mount it on there, and then that bolts onto there, so there's no pulling on this fitting, bending them, re-drilling them. And basically what I want is this to go on here, and then the bracket to support the fuel pressure regulator, because here's quite a big boy and I don't want this falling off. But because we've got a fitting on a fitting, this now doesn't line up with our mounting points there. If we did have the female to male, this would be here, so we would line up perfectly with our bracket. But as we're out a bit, I just couldn't really get this to work. So out of an old bit of angle bracket, we cut out a square, and I've made this little bracket. So what this does is offsets the holes, so we can bolt that on there, then our fuel pressure regulator will bolt over here. So it's got a nice little bend in it, little kink up. It took a few tries, because the other thing I don't want to do is have this misaligned from that, and then when we bolt it down, that'll then put stress on this fitting. So I'll show you how this bolts on, like so. So that goes onto the original mounting points using the original Torque bolts, but then we've got our offset. So you can see the angle is swept up where the bolt holes are to bring this up a bit, because it wasn't perfectly aligned. And now if we hold this flat on the head, when these two come together, you can see they are perfectly tip to tip. So when we're out here where the bolt holes are, we know that's going to be perfectly straight. So we can get our female to female back on and get this bolted up fully. And there it is, bolted up. And as you see, the bolt holes line up perfectly, sits flush with the head, so the bolts drop in and it doesn't put any pressure on the rail at all. I've still got the original Allen keys that came out of there that was for the lifting eye. And they do up like that. So that is a nice tidy install. I'm happy with the bracket. We'll paint it black when we're done. But now we've got our connections there, so we can come off the bottom and return to our swell pot. So I've got some fittings for that. We've got our new hose, get making some lines. I've got the PTFE lined hose, and that means there'll be no smell or smelly vapours in the bay. And also that's what's already fitted, so it'll match all the rest of the pipe work perfectly. Let's just do one last final bonnet check. As you can see in there, There is loads of room above it. The bonnet will come down another couple of millimetres, but that is well clear. If I could get my hand in there, I reckon I could get my hand between that and the bonnet, so we've got no worries there. In fact, I wonder if we can hide the camera. Where can we put you here? There's that, and there's all the way down. So we have got loads of room. We're quite lucky with where it sits is right about here. So if it is here, we've got this sticking out. That's got that sticking out, but we've got a nice big dish here. It's probably about 20 or 30 millimetres extra we've got just where our gauge goes. So very handy. And there's one line made up. So I've got the AN 90-degree fit in there. That runs underneath. I'm probably going to pick up on the bolt hole on the manifold. I've got these little billet P-clip kind of things. So I'll put one of them there. Then that's going to run around. And then it's got to meet our swell pot here. We've got our 180-degree fitting. So I've taped it there. That's going to go right in the middle of that. So I've just got to cut that with a grinder and then put our fittings on. I may shorten the feed down because that is a little bit long and it kind of bundles up down there now. So we could shorten that by 50mm and then that will sit in there. I've got a 45 which might sit in there a bit better because with the 90 that kind of goes over here. With 45 that would nicely hide under that pipe. So let's pull this back out and I'll show you how we put the fittings on. So the reason we put the tape around before we cut is because when you get to the end, if you just cut it, all the braid will just splay out. So you put the tape down and that holds it in. Otherwise, you're not able to get your fitting to slide on. So I'm going to cut that right in the middle, just straight through with a grinder, like so. So now the braid's nice and close because I need to get the first part of the fitting to slide over. So with the tape on, you can squeeze that on. But if the tape wasn't on, this splays out and then you can't get that on. And the next bit is to get our little collet in, and that's got to go over the plastic, but under the braid. So it slots in there. Now, Torx did send us a little tool that does that, but that's an Autoshack at the minute. I haven't got that here. So I've just got to carefully make sure the braid doesn't go on the inside and that goes over, and then you just give it a good whack. So we'll take the tape off so then the braid can splay out. And then inside here, there is a little step at the bottom so you know how far it's got to go in. It comes to a stop, and then we can put our fitting all the way through all of it, do it up, and that clamps it all together. So let's try and wiggle this on. So as soon as the tape comes off, you can see that has started to flare out. So if that was flared out, we'd never get this. Carefully, that's got to start in there. See the braid is flailing out. And then quite subtly, the best way I found to get that down is just give it some wax. And inside there, that Teflon liner has now gone all the way down to the step. So this goes down, and what you can see now is the outside braid is going to be clamped between the inner collet and the outer thing. Yeah, so now we can just push this in, nice snug fit until that comes to its end. So now you can see the braid is all flared out. This has got a cone on the inside, so as it pulls in on those threads, that's going to clamp it all together. Now we can do this up. Again, we have got a nice vice attached, but that's the Autoshack at the minute. So I'll tape up the vice, get that in there, then we've got our AN spanner to do this up, and that will be fully connected. So we're making do with what we've got, protecting that, and then this we just do up until it reaches the bottom. And there we are, one fitting ready to go, all unmarked and good. So let's try it back on the car. The good thing about these is you can orientate them where you want. Let's roll. And all back in. There's our end, that end. And the good thing that you can orientate it whichever way you want. You can make the curve of the pipe, because obviously it's been in a roll, make its natural angle. Some of these don't have it, so when you do it up, you're kind of stuck at an angle, and it's really awkward then to get the hose to run nice. But you can just let it relax in its normal state, and we can put them back on. And no stress on the pipes, no stress on any brackets. Sitting in there nicely. So let's finish off this feed, see if we can get this sitting a bit more relaxed. And then that's nearly our whole circuit complete, so we can start pumping some fuel through it. Because of course, as cool as it does look, we have got to make sure it does work as well. I've taken a completely different route for the feed. I went down to the pump and flipped the union around 90 degrees, so now it comes up there, straight in there to a 90, so that's a nice short route. That was the old one, and it came up, down, under, up through here, and then across and over. So that's really tidied this side up now. We've just got those two pipes coming in to and from the tank. So our feed comes in from the pump, up into the rail, out of the regulator, down, and then just swoops in there. I think that's a much tidier install. So you can see on the end of the pump, that's just a banjo. So I loosened it, flipped it round 180 degrees. So that now heads straight up to the inlet. So I just disassembled everything so I could blow out all the lines, make sure there's no debris in the new hose or where we've cut it off. I put thread sealer on all the fittings that go into the fuel pressure regulator, just painted the bracket. So while that's all drying, I thought I'd check out the other end. So I've removed the rear seat, and in the back we can see where the AN fittings go into the fuel tank. So I'm just going to take that sender out and just double check that everything is in there. Because we've done so much work on the front end, I just want to make sure this is feeding properly. But as you can see in here, the colour change respray was really everywhere. There's none of the original colour anywhere. And we've got the candy red even under all the seats. Looks like there's a little panel that they've made up. So let's drill out them rivets and I'll pop that sender out and check everything is all right there. And that reveals all our AN fittings. So we've got the compression fittings converting it to AN, and then we've got some angles so it swoops around. So I'll undo them and then we should be able to rotate that and that should pop out so we can have a look in there. Already got a little red dot there, little red dot there, so we know which way round they go. So lift pump out, but as it turns out, this is no lift pump. As soon as I lifted the top off and saw the blue cap, I knew this wasn't the original pump. And this is a Cytec SYT 620EM. This is a 340 litres per hour fuel pump. This is like an 800 horsepower fuel pump. And this is the lift pump. So they've got 340 litres per hour pump supplying just the swell pot. Seems a bit extreme. But when I spoke to the customer, he said originally when the car was built with the engine conversion, it didn't have the swell pot in the front, which is obviously why they've put it to that. Not ideal, because the Mk1 tank doesn't have a swell pot in it. So anything under half a tank, that would have swashed away and that would have been running dry anyway. But this could also be contributing to why our pressure is building up so much at the front. If that's pumping 340 litres per hour to the front and then just trying to return it, because there's no way the engine is using that much, even with that massive tank, we've just got pressure building up everywhere. So the other thing I'll need to check is a 340 litre per hour pump is going to be drawing a lot of current. So if that's only running on the original Mk1 lift pump wiring, that's not going to be up to it. So I'm just going to double check that as well. This is massively overkill to just supply a swell pot, but as it's here, I'm going to leave it in. And now we've beefed up the front end, that should have it all under control. But yeah, that's quite a surprise to find that in there. So on the topic of wiring, there are so many accessories and so many things added onto this car, which means there is so much extra wiring. I think from what I've found so far, I just want to investigate it a little bit more. It might be all okay, but until I have an actual look myself, I'm not going to give it the super on approval. So I'm going to dive under the dash and see what we have. So on the cabriolets, they have this extra 2-part dash. They have like a strengthening beam across. And what that's allowed is access to all the wiring. So if we look under here, we've got the CE1 standard Mk1 wiring, but it has got so many extra fuses added on. Got inline fuse, inline fuse, inline fuse, inline fuse, inline fuse. On the fuse box itself, it's got extra relays on the top, big extra fuses, but no indication what any of it is. It does look like a little bit of a spaghetti, which isn't necessarily bad. These are all quite messy as factory, but we just need to identify what everything is. We've got the ECU sitting in here, and with those fuses and a relay, I'm pretty sure they did say they used a Vagtronics loom, but they have used the power point out of like an Audi TT or something, so that might have came from the donor. But everything's mounted nice, everything's sat in there nice. And one thing I have discovered here, which I've never seen before, with the 6-speed gearbox, there's no cable takeoff for the Mk1 Speedo, so I guess you normally go without. But this little box of tricks is like an electric motor, and it connects to the Speedo cable out, and it's got a GPS antenna. It's made by Speed Hut. It's called the Speed Box. Never seen anything like this before for the Mk1s, but that has solved this problem. So it's a GPS feed which runs a motor, which then runs a Speedo cable, which goes in the back of the clocks. So I am a big fan of that. I'm going to be looking into that in the future for future conversions, even for the flush bays where I don't want a Speedo cable in the bay. That is a pretty cool little mod. And then over the driver's side, we've got our electric power steering conversion. Looks like a Corsa C or something like that. We've got the hydraulic clutch conversion, we've got the drive-by-wire throttle. Everything is very, very busy. We've got all the wiring for the heated seats and the electric windows. That's all behind here as well. I think this is to do with the CD player. That's a Pioneer box. That looks like a GPS aerial as well, so that might be for a sat-nav. We've got an aerial tucked under here, so maybe because I don't know where the cabbies have it. I reckon this probably normally on the wing has been smoothed off. But I just want to make sure this is safe and really label everything up, because in the future that is going to help everybody. Obviously the person that put all these extra fuses in know what they do, but at the minute we don't. And if you've watched previous episodes, you would have seen following the wiring is my absolute favourite part of a build. So let's continue the investigation. So with a bit of research, a lot of probing with a multimeter, a few wiring diagrams, and just simply following the wires, we are now making sense of it all. And there's some very clever ways they've solved some problems. The heated seats are pretty much a standalone. They've just taken a feed, power to them, and they're self-contained. But to get the switches to work, the switches themselves don't actually mount to the bezel. The bezels are just on the outside. So they've made this plate with these brackets that fits the plugs in just like they'd be in the TT. This is mounted, and then the switches are free on the outside. But they don't actually touch the bezel. They go all the way through them. So you can see there, that was a little fab project for someone to make them brackets for the switches to work, just to keep the TT seat buttons. Also in there is the electric windows, they're all connected up. And then on the top of our fuse box here, these are for the central lock-in, one way for lock, one way for unlock. That's controlled by the alarm. We've got the big fuse for the EPAS, and then these fuses on top are also for the central lock-in. And then what I've found out, we've got the relay board here from the TT, but usually there's a big relay here, and that's for the wiper motor. And what they've done, they've cut that out and then put the Vagtronics engine ECU conversion fuse box in that spot. So these aren't actually fuse spots for a TT. There's usually one big relay here, and they've connected all the main wires coming in just as it was in the TT. So we've got our battery live coming in, all the link, and then we've got the plugs on the bottom, which activates the relays. So we've got our ECU controlling this one. They've repurposed the fuel pump relay as the 100 relay that's usually in the 20 valve turbo loom. So they've got all that wired in, and that pins and goes through to the fuse box. So a very cool way. I might even do that myself in the future. And then they've made little brackets for the ECU, so it all sits in there really, really nicely. I found the heated screen relay because it's got a front heated screen up here. So the relay for that is all in there, and that works off what would be the rear button in a hatchback, and then the relay activates the heated screen. The only thing I'm not too happy about is both fuel pumps are running off the standard Mk1 Golf fuel pump relay. So I might change that just so they're and just so they have separate fuses each. Here's where the loom comes in from the front fuel pump, and then that just tees into the wiring loom there into the main fuse box. Like I said earlier, that's the GPS speedo drive, and I found that the GPS aerial comes up, and we've got the GPS aerial over there for the speedo. We've got the GPS aerial over there for the nav, and then we've got the DAB radio there, and there's our wires for the front heated screen. So although it does look a bit of a mess, it is all starting to make sense. So we'll get this all tidied up. Everything is working. It's just a little bit messy. The only thing I am going to change is I'm going to put each fuel pump on its own relay and own fuse, just so they're separate and the load is then split between them. Apart from that, I think it's all okay. But for me, what a fun couple of hours that was. Pop it all back in. There we go. Right, so AN fittings are all back on. These are all the same fittings that were on there before, just bolted back. We've got our feed here, then our return back to the tank. So now we've got the wiring. So I just want to have a look at this because this is all a little bit sus as well. As you can see, the wires have been joined and their colours change here. And then just a little bit further back here is where they've been joined the other end. So this is an original Mk1 loom. We've got the thick red and yellow, which is fuel pump live, and then we've got a thick brown, which is fuel pump earth. And these must be from the original caddy. These are the fuel sender wires. We've got purple and black, and then a thinner brown. So the fuel pump live goes to the red, fuel pump live goes to the red, which is the center one. That's correct. We've got our thin brown just chilling. That's not doing anything, but we know our earths are shared in the pump, so that's no big deal. We've got our purple and black, which is our fuel sender that goes to the fuel gauge, going to white and red. But when we come up here, white and red goes to brown, which is the earth, which we know on this one, our earth point is that little tab there. So the fuel pump and the sender has been earthing on what should be the gauge. And then our brown comes along, that turns into black. Black goes to yellow, which is the terminal on this end, which goes to a fuel sender. But this is turning into one of those cars where I have just got to check everything. So now I'm thinking about where does the power come for these pumps? I don't know where the relays are. I don't know if they're fused. I think I need to look into that as well. So I think I am going to rewire a lot of this. I mean, we can get rid of all of these independent fuses, inline fuses, all these loose relays, all these inline fuses. We've got all the relays and bits up here for the heated screens. this can all be done a lot nicer. It does all work at the moment. So for now, I think I'm just going to switch those wires around on the fuel sender, but ultimately I'm going to run new wires all the way through, replace this loom that's been cut and swapped all the way back to the fuse box. But what I'm going to do at the moment, I'm going to bridge the rear relay. I've got the front pump disconnected, so then we can fill up the swell pot, check for leaks, and then we can go for a start. So number 2 is the fuel pump relay on a Mk1. I've got my little bridger in here, and we should hear the rear pump fire up. Yep, that definitely fired up. So that's pumping away, and that should be filling up the swell pot, which I think it is. That didn't take long. But if we do a bit of quick maths, that's 340 litres per hour, so that's 5.9 litres per minute. This is a 1 litre swell pot, so in theory, that'll only take 10 seconds to fill up. That is how much fuel we're actually moving. But everything looks good. We've got no leaks or any of the fittings. What we can do now is turn on the front pump, and that'll pressurise up the rail, and we'll see what pressure this is preset at and check for leak. You can see we're actually getting some pressure in the rail from the swell pot being filled, and it's actually building pressure because it can't get rid of it quickly, so it's going up into the rail. Admittedly, it's only half a bar, so it's nothing to be worried about, but that could definitely be contributing to our old fuel pressure regulator struggling. Right, I'm going to go and connect up the front pump. And that has popped us straight up to 4 bars. So that's what it must be preset at. And it is quite a noisy pump considering it's under the swell plot, so it's fully submerged. That is quite noisy. But now the high pressure system is running up here, through the rail, through the regulator. We're sitting at 4 bar, back round, and then back into the swell pot. So this is fully adjustable, which is the whole point of fitting it. So I'd like to get that down to 3 bar just so we can start at the basic setting. So I've just loosened the lock nut, then with our Allen key, we can move the pressure up and down. So we want to go down, but we could go up. 5 bar, 6 bar. So the fittings are definitely capable, but we want to be right down at 3. And you can hear the tone of the pump changing as well as we're upping and down the pressure. Now we can lock this back off, and that'll be a good starting point, and our rail's already primed. So we'll take our bridge back out, silence, put our relay back in. So I just had a good check around when it's all under pressure, and we've got no leaks, no problems with any of the fittings or lines. The fuel system's all primed up, so it should fire straight up. Just like that. So you can see now we've got a vacuum. It's pulled down to about 2 3/4. If we take that vacuum off, that goes to our 3 bar base. That's all good, even when it's running. Everything's looking very happy, and got no leaks. Everything in the back is all looking good. We've got no leaks here. Everything's happy. I can feel the fuel rushing through. I'm going to want to do something a bit more substantial in here because this just had this plate covering that, but we're not really fuel tight to the inside. We could really do with the cover that used to go on there. We wouldn't be able to put it around this side because of that, but we could make something. So I'm going to make some little kind of enclosure or something to go over there because that's not really cool. That's literally the outside of the car. That's the floor down there. But all very happy. So I'm going to mark this fuel system as complete, leak-free, working, and most importantly, we have now got it under control. We can set the fuel pressure to what we want and it will stay there. We're not going to have this creeping, we're not going to have this unknown fuel pressure. So with that in hand, we can now get it back to mapping. So unwrap it all off. Revealing the candy red again. So I am super happy with how this has turned out. Is it overkill for this engine? Absolutely. It does not need this size fuel system on it, but to solve the problem of the creeping fuel pressure, just made a great excuse for some upgrades, and even better, it looks awesome. But I'm not happy how it's been wired inside. with everything running off the standard fuel pump relay, nothing separate, no separate circuits. So the work on this is going to continue into a wiring episode. Next week, I'm going to strip out the looms, start making my own loom for the fuel system and all those other accessories that are in there for the heated seats, the alarm, the central locking, the electric windows, the EPAS. I'm going to combine that all together so it's not just a bit add-on. The other thing he's always complained about is the lights are a bit dim. Common problem on these, because there's no lighting relay, it all goes through the ignition switch. So I'm going to make probably a full front half loom and a fuel loom for this, which as you've seen before, is music to my ears. Wiring is my absolute favourite part to do on a car. So fuel system is tick. Next week, we're going to be on wiring. So I'll make an order, make up some nice little fuse boxes and relay holders. So we have a nice, neat little install under the dash, which not only will make it more reliable, if we have any problems in the future, it'll just make diagnostic much, much easier. I hope you've enjoyed this video. I'll put a link to all the parts I've used in the description. So I'll see you same time next week with the Mk1 again for some wiring excitement. But until then, make sure you have fun.